Low-grade heat is abundant, but efficient low-grade heat recovery is still a great challenge. So here we propose an asymmetric thermal cell with a high energy efficiency over 3%. The asymmetric thermal cell is thermally charged and electrically discharged under isothermal operation. So it has potential for various applications due to its flexibility, low cost, and lightweight.
The performance of asymmetric thermal cell depends heavily on the content of oxygen functional groups and the quality of electrodes. Researchers are suggested to strictly follow the protocol. Visual demonstration helps better understand the structure of asymmetric thermal cell as a new technique and ensure the production quality.
Demonstrating the procedure will be Kaiyu and Wang Xun, graduate student, and Dr. Huang Yu-Ting, postdoctor from my lab.
To set up a cold water bath, place a double-wall glass beaker on a magnetic stir and circulate ice water through the external layer. Pour 100 milliliters of sulfuric acid into the beaker and turn on the magnetic stir. Add 1 gram of sodium nitrate to the beaker. Add 1 gram of flake graphite to the beaker containing the sulfuric acid and stir for 1 hour in the cold bath. After 1 hour, gradually add 6 grams of potassium permanganate to the solution. Stir the mixture for another 2 hours. After 2 hours, replace the ice water in the external layer with the water at a temperature of 35 degrees Celsius. Change the reaction environment to 35 degrees Celsius for further